Good morning everyone. Welcome to my video presentation. My name is Tan Shin. I would like to express my appreciation to all who watching my video.
The title of my undergraduate project group is Electrochemical Behavior of Anodized and PCl coated AZ91 magnesium alloys for biomedical and industrial applications. These are the objectives of the project: to measure and compare the corrosion behavior of AZ91, anodized AZ91, and PCl coated AZ91 in simulator body fluid and simulator seawater. The purpose of using simulator seawater and simulator body fluid is to simulate the seawater environment and physiological conditions in human body respectively. The anodization and PCl coating are methods to protect the magnesium alloys from aggressive environment. And this is the UGP overall flowchart. In result and discussion, the main weakness of the magnesium alloys is its high corrosion rate. It can be improved by surface modification. It is benefit if the corrosion rate of different surface modification of AZ91 magnesium alloys can be discussed and then finding out the most suitable surface modification for different applications. This shows the microstructure of AZ91. The basic microstructure consists of primarily alpha phase in which aluminum-rich beta phase is precipitated along the boundary of the grain. And the left side shows the SEN image, the right side shows the EDS spectrum of AZ91. It shows the information about the surface, topography, and chemical composition. The chemical composition of AZ91 can be observed that the magnesium alloy is different in beta and alpha phase. In alpha phase, there are magnesium oxide and aluminum, while in the beta phase, there are an addition of zinc. In beta phase, the chemical composition matched with the composition of AZ91 magnesium alloy. The presence of beta phase in microstructure result in higher tensile and ductile properties. Therefore, the AZ91 magnesium alloy is the suitable magnesium alloys for industrial application, as it has excellent tensile property after reviewing to some journals. Therefore, it is able to fill the application of the specimen in the project, which are biomedical and industrial application. The effect of PCl coating on slowing the degradation and improving corrosion resistance has been investigated. They found that the modified ceramic scaffold with PCl polymer could control degradation. Based on previous study, the application of PCl coating can be an effective method of controlling magnesium alloy degradation and bioactivity for tissue engineering applications. Therefore, PCl coating is selected in the project to increase the corrosion resistance of AZ91. The low current density of AZ91 during anodization was attributed to the formation of a high impedance anodized valence on the surface. Based on the SRD pattern of anodized valence, there are the presence of magnesium aluminide, magnesium oxide, magnesium and magnesium hydroxide in the anodic valence on the surface. As mentioned before, magnesium aluminide beta phase will result in higher tensile and ductile property that is suitable for industrial applications. Magnesium oxide also considered to be the key constituent of anodized valence on magnesium alloy. When the surface is in contact with corrosion environment, magnesium oxide will degrade first to protect and slow down the degradation of AZ91. The anodized valence makes AZ91 a better corrosion resistant. Therefore, it is effective method for controlling magnesium alloy from degradation due to the formation of anodized valence, and it is suitable for industrial application. comparison of corrosion rate in simulator body fluid and simulator seawater, it considers the ion concentration in both of the solution. An assumption can be made that simulator water is more aggressive than the simulator body fluid. This is because of the higher content of chlorine ion in simulator seawater than in simulator body fluid. The concentration of chlorine ions in simulator seawater is 145.3 to 153.8 nm, while for the simulator body fluid is 103 to 148.8 respectively. The higher charge transfer resistance indicates the specimen has good corrosion resistance. It can be supported by the nyquist. In the nyquist, the dimension is directly proportional to the charge transfer resistance. An increase in the dimension will correspond to the increase in corrosion resistance. Therefore, the corrosion resistance of PCl coated sample is higher than uncoated sample as the dimension of the semicircle of PCl coated specimen is bigger than uncoated specimen. It may be due to a thin formation or layer, offering sufficient protection for the substrate against corrosion. It shows the nyquist board of the untreated and anodized AZ91. This is clearly show that the corrosion resistance of anodized sample is greater than untreated one because the dimension of anodized is greater than untreated one. In addition, there are no comparison of corrosion resistance between anodized sample and PCl coated sample in the project. This is because that the applications for anodized sample and PCl coated sample are different, which are industry application and biomedical application respectively. Their material properties are also different, therefore there is no comparability among them. The corrosion potential and corrosion current density characterize magnesium alloys resistant to corrosion. A high corrosion potential, a low corrosion current density are indicating of good corrosion resistance based on previous study. It is supported by the taper block where the anodized AZ91 has a lower current density and a higher corrosion potential than untreated one. This means that the anodized AZ91 has a better corrosion resistance than untreated one. Additionally, the PCl coated magnesium alloy has less susceptible to corrosion and has less corrosion rate than uncoated one. It can be supported by the study of Bashoshi rate, present that the more negative corrosion potential of uncoated compared to the coated one. PCl coating showed a lower corrosion rate than uncoated. This is because of coating preventing interaction between the electrolyte solution and substrate during immersion. There are similar statements that PCl coated AZ91 has better corrosion resistance than uncoated, and also anodized AZ91 has higher corrosion rate than untreated one based on EIS and potential diameter correlation. Corrosion rate of magnesium alloy can be analyzed using a very simple and traditional immersion methods as a function of degradation time. The degradation process of magnesium alloy can be monitored by tracking parameters such as wear loss or shift in pH. Wear loss of anodized specimen and untreated specimen increase with immersion time, but the wear loss of anodized specimen is less than untreated specimen. This means that the corrosion rate of anodized specimen is lower than untreated specimen. In another study also showed that the uncoated sample suffer for corrosion attack compared to the PCl coated one. This is obvious that the anodized AZ91 and PCl coated are more protective against corrosion than untreated AZ91. This can be explained by the occurrence of corrosion attack in uncoated sample is due to higher corrosion current density and lower electrochemical impedance of the uncoated sample. The change in pH indicates the occurrence of corrosion of specimen. As we know, magnesium degradation will make the surrounding more alkaline or increase the pH value. However, there is decrease in pH value during immersion. This is steady due to the corrosion product formed on the surface, protecting the surface of substrate, causing the pH reduce. With the balance between the protective effect of corrosion product and corrosion effect of solution on magnesium alloys, the pH marginally increased and gradually level off. Although there was a fluctuation in pH value of corrosive medium, it is overall considered that pH value of corrosive medium increased, indicating the corrosion occurs. In conclusion, a PCl coated and anodized filament on magnesium alloy was studied. The electrochemical showed that the corrosion resistance of anodized magnesium alloys is better than untreated one, and the corrosion resistance of PCl coated magnesium alloy is better than uncoated one. Immersion tests also indicated that PCl coating and anodized filaments can effectively protect magnesium alloy against corrosion. It is demonstrated that surface modification of magnesium alloy like PCl coating and anodized filaments is an effective and post-mixing one-step approach to prepare protective surface layer and to improve the corrosion resistance of substrate magnesium alloy. There are a few future work recommendations such as for PCl coating. A deep coating method can be used. It is advisable to use deep coating equipment to avoid human error as much as possible and also to get consistent coating on the surface. Besides, a dehydrator should be used in storing magnesium alloy. In the process of preparing SPF, a basket beaker should be used rather than a glass beaker. And it is followed by the UGP gun chart 1, and also gun chart UGP 2. This is all the reference in the slide. Thank you.